Hey guys, so let's talk about VPN and okay, so what we need to we will be discussing today and a big lab, huge lab that I had to actually go through the whole thing step by step and had to create my own. So I had to create my own lab steps for this lab. This is site-to-site VPN. Um, so it's kind of, really a big stunt. Well, there's just a few VPN steps in this lab, but it's all about VPN, and they were going for site-to-site VPN. I have created some old documentation there, so I'll be sharing with you the I think 70 or 80 screenshots in this Word document because obviously we don't configure site-to-site VPN every day. So any one small step missed and it's not gonna work, right? Uh, and then I had to do this lab again, obviously, after the last lab I checked. If there are any changes, yes, there was some slight changes from previous lab in this site-to-site VPN lab as well. So that's why I'm gonna have that documentation on my left side, the other screen, and I'll be sharing that documentation with you, obviously, the new documentation and the old one as well, just for your reference as well. But the thing is that documentation is, so let me just show you the other one as well, which is the new one, where I have put arrows and lots of stuff, but obviously it doesn't explain anything. It just tells what are the steps to take. So in the video, obviously, comprehensively, you will see everything uh, that is going to make sense. Okay, so AWS VPN, that is, if we go to our AWS console. Okay, what's this? Screenshots. Go back. Go away. So AWS VPN is obviously part of the VPC dashboard, and it is there's a point-to-site VPN where a user connects to the server, to the environment. Let me just close all this. There's a lot of mess here. Oh, there are more. Okay. Anyway, so what is VPN first of all, and why do we use it? And some of you may have used it in your office environment as well. Um, and that's what we're gonna do, but on AWS. I have configured, so the company I work in, there we use Microsoft. It's all Microsoft Shop, though we are now slowly moving towards AWS as well. But there I have configured the Azure VPN gateway, so for the clients to connect. Now, first of all, it's VPN, virtual private network. The virtual private network. So, when we go back and check, so AWS VPN or AWS Virtual Private Network, AWS VPN lets you establish a secure and private tunnel from your network or device to the AWS global network. And obviously, I should add there over the insecure internet. So over the internet, you're connecting from your house or from some place to another place, or from one branch to another branch over the internet, where well, everyone else is as well. So obviously internet is considered insecure, because there are hackers always all the time trying to sniff into any kind of traffic that is coming from any kind of endpoint that they're interested in. So the VPN just provides a very secure private tunnel between two branches, and or between one person who's connecting from home to their network. Now you guys might have used VPN before. So first of all, yes, anyone has used VPN, and which VPN you have used? Cisco, if you have used that. So anyway, right? Yes.
No, yeah, we do use it. It's Juniper. I think it's called something else now. Juniper just was
Yeah.
sold. Uh,
Mhm.
it's a Pulse. It's called Pulse Secure. It used to be called Pulse Secure. I don't think it's called that anymore. We just
Mhm.
recently heard that it was sold to some other company.
Oh, okay. Okay, I didn't know that. Yeah. So, but you've used Juniper VPN. Okay, that's great. And so we're going to there is point to site VPN, as I was saying, and then there is let me just create a diagram quickly here. Suppose we are at home. So this is the branch. Suppose an on-premises branch. Obviously, we don't have one in our environment, but suppose it's on-premises Toronto branch. And what used to happen was that obviously all the services were inside the branch. There are domain controllers, there are web servers, there are print servers, file servers. So users used to connect from home to uh, the company VPN server, and from their VPN server would do a connection check, and protocol check would take place from the home. There had companies issues a security certificate, and that security certificate is given to a user for the duration of his or her employment, like yearly auto renewal if there is. So security certificate would be renewed. That security certificate would tell that if this user is a legit user and the certificate is valid, you could just revoke the security certificate as well. Or whenever the user makes a connection through VPN client, so uh, the security certificate would be checked as well, and then the connective connection protocols would be checked as well, and then the user would be given an IP from the VPN server, and once the IP is received, then you can connect or log in the background backend environments. So, but now this is point to site VPN. So, we're talking about site to site VPN. So, point to site would be one person connecting to from home or office, or from some hotel or any destination to the office network. Then there is site to site VPN, where two branches are connecting with each other. So, two branches are connecting from LAN to WAN, and through site-to-site VPN. Now, those who are Cisco or network gurus, they would have configured the VPN on the server side, on the device side as well, and configured it for the clients. But then now there is cloud as well. Before it was branch to branch over the WAN. Traffic would be connected to each other. Then came the cloud. So in the cloud now, suppose you're from the branch, from some on-premises, you're connecting to AWS or Azure, resources. Pretty much many of the companies have resources there. So there are VMs, there are databases there, and other services for the company that needs to be accessed in the cloud. And for that, um, now when we say SaaS-based services, so SaaS-based services, which is just software as a service, right? So it's just ready-made software, like MS Office. You just connect online, you just log in, already there. You don't need to install, suppose it's MS Office online, right? Or Office Docs or G Suite, Google Suite. So you don't really need to do anything, but only just log in, create a username, and just log in and pay monthly, right? So you don't really need then VPN services to connect to SaaS-based applications, which are just in the cloud. They're already deployed. You create an account and start using it right away. But when it comes to uh, cloud infrastructure as a service, when it comes to IaaS, then it is necessary that whoever is connecting to your infrastructure, which is in the cloud, means that virtual machines, you're pretty much connecting to a data center, obviously. So when you're wherever you're connecting from, that needs to be checked, and whatever. Although when it comes to SaaS-based services, obviously your machine should be still secure, but you don't need VPN really. In fact, I was checking with Microsoft for our Exchange, Microsoft 365 services, which is Exchange Online, SharePoint Online, which is heavily used. And for that, I was checking if we need people are going outside country and they're connecting. So do we need to give them VPN services? So Microsoft says that no, for SaaS you don't need that, but for IaaS, yes, you need that. So IaaS, we have in AWS, we have EC2 instances, we have databases, we have a huge amount of services there. So when the users are connecting from either a branch or from home, so they need to actually use VPN. That is fully recommended. And you might be having more privileges, and you are actually creating machines. You may have the delete privilege as well. You may have the modify privilege as well. You're making changes to the databases. So that's all very sensitive tasks that needs to have cross check from where you're connecting, what is your connection security level, and are you who you say you are, or is somebody impersonating as you to be to connect to you the critical resources. So IaaS based services do need VPN, but then this is point to site. We are talking today about site to site, and the scenario could be that you're connecting from an on-premises branch to AWS, or you could be connecting from AWS to AWS. So that is it's cross region, right? So obviously AWS to AWS is you're in East US and you're connecting from West US or East US to Europe or Asia. That might AWS already has backbone network through which is pretty secure, through which dugout lines and submarine lines, right? So through that backbone network, you can make a connection easily. But when you're connecting from on-premises, a Toronto branch or New York branch or wherever, so you have to connect to internet, obviously. Uh, that is all the Wild West, we can say, the to the internet, to the WAN, and through that, unless you have purchased that dugout dedicated line to the nearest data center of AWS, so then it is secure, yes. Still, you need VPN for that too. But if you're connecting over the internet to AWS, then definitely you need site-to-site VPN for that. What we're going to do is that we're going to um, pretend that we have another branch, and we still will be in the cloud. We still will be using another region, but the way we will be connecting the two sites or two VPCs in different regions will be through VPN, and through we're pretending that we're using the whole um, the internet, not the backbone network of AWS, and then we're going to create those site-to-site connections between two VPCs in two different regions. And obviously, for the branch, you should have, if we need to pretend as a branch, obviously, we need some kind of better equipment there from which we can connect. Obviously, you need to have a VPN server or a VPN router there. We don't have that, so we're going to be connecting through one AWS branch VPC to another across the region. But let's just discuss again about VPN. And if we go, there are two types. We already discussed about that: AWS site-to-site VPN and AWS point-to-site VPN. Today is AWS site-to-site VPN only. So as I said, that I had to redo the whole lab just to check that if there is any change. So thank God that I did that and did find out that my AWS did make some changes across the time. So obviously that always happens. There's always changes. Uh, okay, so then AWS site-to-site VPN enables you to securely connect your on-premises network or branch office site to your Amazon Virtual Private Cloud or Amazon VPC. AWS Client VPN enables you to securely connect users to AWS or on-premises network. So we're going to be creating a gateway. I'll be explaining the whole thing that how we're going to be creating two branches or two sites across the regions, and then what exactly, how many types of gateways we're going to use, and then the VPN gateway. But a little more about site-to-site VPN. So you can have up to five customer gateways. Okay, we're going to be talking about obviously customer gateways and virtual private gateways. But customer gateways simply means, as the word says, customer. So whoever is, whichever client side or customer side is making a connection to your office environment. Uh, so customer gateways always help the other side to connect to your VPN, and we're going to be configuring that today. So you'll see that. But we can have five customer gateways per AWS account per region. So if you have one AWS account in East US, so five customer gateways you can create there. But we're going to be creating a customer gateway. We're going to be understanding what it is and how it is configured. You can have up to five virtual gateways per AWS. So virtual gateway is the VPN side of gateway. In the diagram, I'll be explaining that. You can have up to 50 site-to-site VPN connections per AWS account, per AWS region, and you can have up to 50 site-to-site VPN connections per virtual gateway. So again, the virtual gateway, the word comes here. I'll be explaining in this diagram what are those. You can advertise up to 100 routes per virtual gateway, 100 different routes. Learn more, please visit VPN limits. So then that's the link here, but they always do make some updates as well. So I'm just going to open that and share with you as well on the chat. Just copy this and put it in. Okay. So Amazon VPC quotas, and that is the following table is the quotas formerly referred to as limits for Amazon VPC. Yep, same VPS per region 5. Increasing this quota increases the quota on internet gateways per region. Subnets per VPC 200. If you're creating VPC, it's 200 subnets. You can create IPv4, cyber block 5 ranges you can use, and V6 also 5 ranges you can use. So that's VPC quota that we're talking about. And I'll just put here AWS VPN. Uh, okay, side-to-side VPN. So I'll just put that here. And so yeah, they explain how it is. I'll just put that in WhatsApp as well and in the slide for later read as well. And obviously, you have to check the prices as well. Pricing. We're talking about side-to-side VPN. So I'm just gonna go there, or um, and that's the page for this. Benefits: highly available, secure, accelerate applications, robust monitoring. Okay, so all VPNs are doing that, obviously. And application use cases, application migration, then you're doing side-to-side VPN. But obviously, you need it all the time when you are communicating between on-premises and AWS site. So overview, features, pricing, and I'll just put the pricing as well here, which is so 0.05 cents per site-to-site VPN connection per hour. So that's for big companies, that's nothing. But when they should be then talking about the bandwidth that they will charge. So there you can create an AWS site-to-site VPN connection to your Amazon VPC in US East Ohio. The connection is active for 30 days, 24 hours a day. You transfer 1000 GB in and transfer 500 GB out to this connection. So pricing example, AWS site-to-site VPN connection fee. There is an hourly fee for AWS site-to-site VPN while connections are active. So guys, one more thing is, suppose you're not transferring any data uh, between the VPN, right? So then the connection actually is not active. It becomes inactive unless you start transferring some data, then it becomes active. So as soon as it becomes active, then per hour charges start applying. Uh, and So that is the case with some VPN providers. But here they are saying there's an hourly fee for even while connections are active. Okay, so they say that while connections are active. So suppose you're not transferring and you haven't transferred data for few hours, so obviously that's not charged. For the East Ohio region, so there are region-based charges as well. It could be different, slightly different. The fee is 0.05 cents per hour. You pay $36 per month in connection fee. Data transfer out fee, that is outbound. The first 100 GB are free, so you pay for 400 GB at 0.09 cents per GB. Okay. So obviously, B does matter. You pay $36 per month in data transfer out fees. But that's how it is. You pay $72 per month for AWS side-to-side VPN. So examples go on, and the pricing you can see as well. I'll just put that there as well. And okay, now back to our slide. Uh, So VPN features, we'll be talking about that. In fact, especially how secure it is, what kind of security it's providing. If I go back to that link, so there are features showing here side to side. So I'll just click that. Okay, so it was the same page where we were before. So I'll just go back to the slide. So AWS side-to-side VPN enable you to create IPsec tunnels, a virtual gateway or AWS transit gateway. Now, IPsec tunnels, IPsec obviously is a very powerful security protocol. And what happens? Okay, you notice that my screen is blinking. Uh, well, I see my screen blinking. Are you seeing my screen blinking as well? As if there's a eyelid opening and closing. Okay. Okay. So IPsec tunnel, we're going to talk about that. Let me just explain first this. Whenever we use VPN, IPsec always comes, or firewalls when we talk about then IPsec does come. So, what is IPsec? So, it is a very powerful security protocol. IPsec is a group of networking protocols used for setting up a secure encrypted connection, such as VPNs, across publicly shared networks. Oh my God, seriously, why is my screen blinking? Um, something. Try to close as many connections or screens here. It's not blinking now. That's where we're gonna do the lab. Just close that. So this means you're not seeing the blinking. Only I'm seeing that on my side.
Yeah, I'm not seeing any blinking. Sorry, not seeing any blinking.
Oh, okay. Thank you for confirming that. Okay, so I'll just keep going. Okay. Um, Now, what is IPsec? How IPsec VPNs work? Now, about IPsec, there are some important things how does it see the connection and secures the connection? Um, it's a framework of security exchanging data over unprotected networks. So it's a framework of for security exchanging. Now, if I just open some of the links here, very to the point things that I just wanted to discuss here are so IPsec is communication rules, set of communication rules or protocols for setting up secure connections over a network. IP is the common standard that determines how data over the internet travels. Well, IPsec, that's encryption and authentication. These are the two major things that you always have to confirm, and IPsec does a very good job in that. Encryption of data of connection and authentication that you are who you say you are, or are you, or is it someone impersonating as you? Or pretending as you to make the protocol more secure. For example, it scrambles the data and its source and unscrambles it at its destination. It also authenticates the source of the data. So, why is IPsec important? The Internet Engineering Task Force developed IPsec in the 90s to ensure data confidentiality. So, data confidentiality is what it does. Integrity of the data checks authenticity when accessing public networks. So, what source are you connecting from? Um, Suppose there was a disconnection, and what happens is man in the middle attack. But if you're connected and you're transferring data, all of a sudden there was a disconnection. Then once you connected again, this time it was not the same source. It was some other person who actually caused that disconnection and then pretend as you and connect it back again. You think that you're still connected to the same source as before, but it's a totally different source pretending as that same source. So it tries to then check that is that the same source. There are session IDs there it creates, and so for example, users connect to the internet with an IPsec VPN to access company files remotely. The IPsec protocol encrypts sensitive information, prevent unwanted monitoring. The server can also verify that the received data packets are authorized. They are coming from the same source as it started. And then what it can do, provide router security when sending data across the public internet, encrypt application data like while it is traveling. So data in transit is encrypted. Authenticate data quickly if the data origins from a known sender. Okay, so known sender, it will authenticate. Otherwise, it will cross check and then authenticate if it is from unknown source. Protect network data by setting up encrypted circuits called IPsec tunnels. So we're going to be, in fact, creating a tunnel, and AWS VPN and other popular VPNs also support minimum two tunnels, which means that if one tunnel is sending and receiving data and it is overwhelmed by a lot of data, or it is not available, then it just either a redundant tunnel or the other tunnel just takes over and keeps sending the data. So called IPsec tunnels that encrypt all data sent between two endpoints. So and then it goes a bit more about security. IPsec encryption is software function that scrambles data to protect its content from unauthorized parties. Data is encrypted by an encryption key, and a decryption key is needed to unscramble the information. They are using scramble and unscramble for encryption decryption. IPsec supports various types of encryptions, including AES, Blowfish, triple DES, Chacha, and DES CPC. So these are the some of the encryption types and levels that maybe you can do some good homework on and check it out. It uses asymmetric and symmetric encryption to provide speed and security during data transfer. So it talks about then encryption as well. Asymmetric encryption, the encryption key is made public, while the decryption key is kept private. Symmetric encryption uses the same public key for encrypting and decrypting. More secure is the PKI, if you may have heard that before, public key infrastructure, which is using asymmetric, which means that there is one key that is public and the private key is with the owner only. So that is considered more secure always. And how does it work? The sender compute. So it talks about all that. I wanted to just mention that IPsec is pretty secure in terms of confirming the authentication, making sure the right people are authenticated, right sources are authenticated, not just in the start of the session, but for the duration of the session, it keeps on cross-checking that it is the same source that I'm still connected to it, or is it different source now? And encapsulating security payload, so it just encrypts data that is traveling or data in transit. And then Internet Key Exchange is a protocol that establishes a secure connection between two devices on the internet. Both devices set up security association or SA, which involves negotiating encryption keys. So they negotiate with each other on encryption keys, and the key exchange takes place. Also, IPsec modes are tunnel and transport mode. We're going to be going for tunnel mode, in fact, and IPsec tunnel mode is suitable for transferring data on public networks as it enhances data protection from unauthorized parties. The computer encrypts all data, including the payload and header, and appends a new header to it. So that is just for data in transit. Transport, IPsec transport mode encrypts only the data packets payload and leaves the IP header in its original form. Unencrypted packet header allows routers to identify the destination address of each data packet. Therefore, IPsec transport is used in close and trusted network, such as securing direct connection between two computers. So obviously, we'll be using tunnel mode because we'll be using the internet to transfer data or to make connection over the internet. And then VPN, so SSL VPN is IPsec VPN, SSL VPN. That's just one more thing. And SSL stands for Secure Socket Layer. It is a security protocol. And SSL VPN is a browser-based network security service. It uses the built-in SSL protocol to encrypt and safeguard. So um, what we need to know from here is that if IPsec protocol is and it's always there with the VPN connectivity. So we are always more secure, and that's what it says here as well. AWS site-to-site VPN is fully managed, that it creates connection between your data center on branch and office with IPsec tunnels. So that's why I wanted to go a bit more in detail with IPsec. What is IPsec? Because that's gonna be the main attraction. Microsoft firewalls they introduced, I think, in Windows 2016, and that was a marketing pitch for them that hey, now our firewalls also have IPsec. I think for Windows Server 2016 or 2012 they introduced that, and before their firewalls were not considered really secure. Okay, so we talked about that, and then I will be now explaining. Um, So I'm just going to go ahead. Configuration and performance. AWS site-to-site VPN offers customizable tunnel options, including inside tunnel IP address, pre-shared key, and border gateway protocol, autonomous system number. We're going to be talking about all those because we are configuring them, so we will be checking those. So you can set up multiple secure VPN tunnels to increase the bandwidth for your application. So it allows you to scale or scalability is there that if there's more data and more VPN tunnels are needed, then it deploys more VPN tunnels as well. In addition, equal cost multi-path routing ECMP is available with AWS site-to-site VPN on AWS Transit Gateway to help increase the traffic between traffic bandwidth over multiple paths. So again, if you are using multiple paths to route your data, so it won't charge. Okay, you're connecting from North America to South America, or you're connecting from North America to Europe. Whatever your routes are, it will charge you similar and not different chargings are there and more or less. So then there is NAT traversal or network address translation is provided. Now, basically, why would we use VPN? One more reason for that is I'm just going to go to the diagram. Before I was asking as well that if our virtual machine here in the cloud has just the private IP, so what are the ways to connect to that machine, right? So obviously VPN was one of the ways. So if it has just the private IP, that's what our target machine will have. It will just have a private IP. So when it has private IP, either you're on the same network or you must have some kind of public IP based virtual machine, as we did the lab before as well. That in within one VPC, one subnet has private virtual machine with public IP and one with private IP. But if you have full VPC which only has subnet that only supports private IPs. Right? Suppose there is one VPC in US East 1 and that is having just one subnet and that has just one virtual machine. It only is having private IP. So then you can connect through VPN from your branch and you can connect to this machine by VPN and private IP. The virtual machine does not have to have a public IP for you to connect from branch to the virtual machine. So VPN will help you connect to a machine with or resources with private IPs. And when there is private IP, obviously you need NAT then in that case. So you need to give internet connection to that machine, which has a private IP, and it stays behind the NAT protocol, so it is safely connecting internet, and nobody else can connect to that machine unless we allow the person. So AWS site-to-site supports NAT traversal applications so that you can use private IP addresses on private networks behind routers, the single public IP address facing the internet. Obviously, that's what NAT do. And monitoring, yeah. So AWS Certified VPN can send metrics to CloudWatch to provide you with greater visibility and monitoring. So we already talked about CloudWatch. We're going to be doing one lab in detail as well for CloudWatch. Yes, you can do monitoring as well. The lab is quite long, so I'll start quickly now. Our lab for site-to-site VPN demo. Um, I have created that the animation actually for this. Let me just closed all the and I had opened that huge amount of screenshots. Oh, did not do. Something that message. So I'm just quickly try to fix that because it's blinking badly on my side. Sorry about that. My second screen. Okay. So, yeah, what's the, and close out. So, I have created that animation type of thing, and I'll be explaining now how we're going to deploy that whole environment. And the first thing is that, so I'll just put this slideshow. Hopefully, you're able to see this. It will start now. So, it's on the other screen, so I'll just. There was a setting here, display settings that let's say duplicate slideshow, right? My presenter, yeah, that is. So, guys, what we're going to do is we're going to deploy, in North Virginia, one VPC, and in North Virginia, we will be creating that VPC A office, and we're going to give an IP range here 10.100.0.0.1/16, and we're going to be creating a private subnet. So we're going to pretend that this is the office VPC to which some customers or clients need to connect, but the virtual machine inside the office is only having a private IP. And they need to connect, and this is the only machine in the subnet. This is the only subnet in that VPC, virtual private cloud. And to this VPC subnet, and obviously the private this EC2 instance, a customer needs to connect from. And obviously, if this machine does not have a public IP, then VPN is the way to go, right? But on the other side, in North California, West US, we're going to be creating VPC B customer, and that would be so VPC A is office, VPC B will be customer, and they will have a public subnet where the IP range would be this, and AutoSign IP would be there. So obviously, why public it is a public subnet because if we were talking about branch. Suppose there's a Toronto branch, right? So Toronto branch customers want to connect to a AWS EC2 instance, right? Toronto branch customers wants to connect to AWS EC2 instance that has private IP. So obviously, the Toronto branch has to have internet connection to connect over the internet to the VPN, and through VPN connect to the machine that has private IP. So that's why we're pretending this is the Toronto branch and it has a public IP given. It has internet connection. Now, today, being a totally Microsoft guy, it's very strange to do a lab with Linux machines. So today we're going all out Linux. It's not very a lot of commands in Linux, but few at least. And obviously, when you're talking about cloud, you must know both type of operating systems. One is obviously Windows, and the other, which is also most widely used, in fact, is Linux. And Linux has so many flavors, but we're going to be using Amazon Linux. But this machine and that machine both will have a Linux operating system, and our end game or the objective is that this customer machine EC2 instance should be able to ping to this machine which has only private IP. And if we are able to ping from here to there, this means that we have um, we have a good connection. So if we are not able to ping from this machine to that machine, which has a private IP, and this is all across the whole, this is West US and this is East US. So from West US machine, which has public IP, because we need to connect to that machine at least, so it has to have a public IP. And from there, we're going to launch a ping. That is if everything is configured correctly. So if we launch a ping, it should ping successfully a machine that has only a private IP across the region, in another region. So we're going to be deploying a virtual machine. Inside the virtual machine or EC2 instance, a Linux EC2 instance, we're going to be deploying a a software called OpenSwan. So I'm going to be telling more detail about that, but OpenSwan will be able to let us connect to a VPN gateway from this machine. And we're going to be configuring it in such a way that it will offer us a VPN client that will initiate a VPN connection to the VPN gateway on the office side, right? So we're going to be using that. If I go ahead, we will be deploying, obviously, when we deploy VPC here, so we will have to deploy internet gateway just like in previous class. That internet gateway will have a route table. We did that before as well. That route table will provide internet gateway connectivity to this subnet, public subnet. Uh, on the office side, first we will creating a basic environment with a machine having private IP, and then we will create a customer side environment, basic environment again. Then we're going to go back to the office side and we're going to be installing a virtual private gateway. What does that do? Virtual private gateway on North Virginia side, uh, this gateway has information about the target or which the customers will be connecting to. So what is the network configuration of the office side? Virtual private gateway will have that information. We're going to install or create another gateway called customer gateway. So customer gateway, as the name says, will have information about what is the public IP being used by this customer branch, and what are the all other information, network information about the customer branch. The customer gateway will have, well, all the office side of network information the private gateway, virtual private gateway will have, right? And once these two gateways are deployed, then we're going to deploy site-to-site VPN using info from VPG. So when we are creating a VPN connection, the VPN connection will need to know the whole network configuration of, or whatever it needs, network configuration of its VPN site where everyone will be connecting. And also VPN connection would want to know who is connecting to it, from which IP range are we expecting traffic, or from which EC2 instance are we expecting the traffic coming from. So VPN connection will be created on the basis of whatever information virtual private gateway has and whatever information customer gateway has. Then we will, on the Linux router, which is the OpenSwan customer side, deploy a router package OpenSwan, and then, we'll be deploying that router package of OpenSwan, initiate VPN. So the main purpose of OpenSwan application or package would be to initiate a VPN connection from the customer side. So obviously, if there is a VPN tunnel established, secure VPN tunnel established between the two, and obviously we will have proof here as well on the target side and on the source side that VPN connection has been made or not. But once the VPN connection is created, then we will be able to ping. We will start pinging from this machine, and it should be able to connect to this machine. If we close the tunnel or just disable the VPN connection, you won't be able to ping. As soon as you open the VPN connection, you will be able to ping across the region from East US, or actually from West US to East US machine, which is having just a private IP. So that's overall what we're going to do. And it is simple to create the basic environment here and there, but it gets really tricky when we are configuring OpenSwan and then we are configuring the VPN client, and it initiates a VPN connection from the client to the VPN server, and then we try to ping at the end. So that ping would be, deciding whether we are successful or not. But overall, this is our game plan. And yeah. So in the end, well, our we will say that yes, the lab is okay if the VPN tunnel details show that the status is up. And if it is up, we will be able to ping from uh, West US to East US EC2 instance. So that would be something that we need to achieve. And in order to do that, we will be then start the lab for that. But that this would be our plan. And obviously, anywhere any small step is missed, and the whole thing will not work. That's how it is in IT. Anyway, so any small step. So every step is we need to take is requires careful consideration. Okay, so that's what we're going to do, and overall, this is the plan. I've already explained that we're going to be creating then VPC-A office and VPC-B customer. And VPC office will be in North Virginia, and customer will be in North California. So just like the previous lab, North Virginia, North California, and our source is going to be North California, US West one, and our target would be North Virginia, where the office is. So let's try to create the whole environment. I'll be, in fact, creating the diagram while I am doing this. So. Okay. The first thing to do is that we're going to be creating a VPC on the North Virginia side. So this is North Virginia. Uh, So US East 1, obviously, US East 1, and that is North Virginia. And that would be the main office. So we can say headquarters. In office slash headquarters to which customers, clients, employees from other side or other branch need to connect. Um, and it will have the IP range here 10.100.0.0/16. And so this would be also VPC dash. We can just for ease of VPC dash office dash just keep it Virginia. From naming it will be easier then. Okay, so we'll quickly create a subnet now, and this subnet obviously the subnet range would be so it's subnet is it's a private subnet first of all. So private subnet and dash office, and its IP will be 10.100.0.0/24. And then we will have a virtual machine that is actually a Linux virtual machine. In fact, there are different Linux machines. We need to be careful. That is one change that I saw there. The latest virtual machine actually does not have OpenSpawn package installation access. It doesn't have it inside, but the slightly older machine has that. Anyway, so we're going to be installing a virtual machine that is the main target of ping. So that would be our private EC2 instance. And so it will have the security group here. Now security group here is going to accept traffic from obviously just the customer gateway or the customer VPC. Customer VPC. But also it's going to accept obviously SSH traffic as well as ICMP traffic. So ICMP is ping. So, well, that is most important. Again, from just the customer VPC. So SSH is just a Linux remote connectivity. You can just connect to through SSH secure shell to Linux machines. So we'll be doing that. Now this needs to be first created, and then I'll be creating the other side, and I'll create. So first we need to reach till this one, and then we're gonna go for the next side as well. Uh, I have here diagram. Okay, so allow all TCP from VCB. Okay, so allow all TCP traffic, allow ping traffic as well. Right. So we're going to be creating that SG with this configuration. Once we're done with that, then we're going to go for the other one. So I'll just start logging into our environment, and that is this. Okay, I'm logged in. Okay. So whenever we log in, obviously just make sure link. I have done a lot of labs now, so I don't okay, 37 cents. Still not bad. Um, in Azure environment, I uh, forgot to close shut down the machine. So for 1 week, actually 2 weeks. So I received a bill of $87. Anyway, it happens in this kind of environment. So, okay, guys, one more thing is that I'm going to be, this is global, so I'm going to go to VPC here, and uh, it is North Virginia, right? So I'll just duplicate this tab here, and then uh, start the EC2 services uh, for North Virginia. So left side is North Virginia or the headquarters, and then I'll just create one new tab, empty tab here. Then I will be just duplicating it on the other side. So the tab is on the other side. This is the VPN, but this will be our US West 1, North California. And the duplicate tab here for North California as well. And that would be for the EC2. So um, one Virginia VPC dashboard and North Virginia EC2 dashboard, and one North California US West one VPC dashboard and EC2 dashboard US West one or North California here as well. So the differentiate between the two. This would be the new tab would be in the middle. I'm going to the left side, which is the head office, and it's the VPC dashboard. So according to the diagram, um, this is what we need to create right now. So I'm just going to start creating that. So here your VPC and do not touch. Yeah, so it's North Virginia. There's an alert. Notifications. There are notifications here. The cloud always take every notification seriously. VPN redundancy loss, VPN redundancy loss. Okay, so yeah, I was doing some experimentation on that or trying to check the whole lab. So when there was a data loss, so it said VPN redundancy. Actually, I deleted that, so that's why it is giving notification for that. Okay, so creating the VPC, I'll just click that VPC only here, and I'll go for VPC dash office dash and dash Virginia. Okay, VPC dash office dash and Virginia, and the range that we put there 10.100.0.0/16, and port, yeah. So yeah, that's just VPC. We've created that so many times. Once the VPC is created, I'm going to go for subnet. So I'll just go for your VPCs. And yes, there's a VPC office and Virginia. Subnets, I'll go ahead and create quickly. Create subnet, connect it to the VPC dash office dash and Virginia. And so it's private subnet dash office dash and dash Virginia. And just for organization's sake, I'll give it 1A, or it could choose itself as well. And subnet range would be the same, 24. Done. And obviously, we're not going to check that option there or leave it empty. It's subnets and enable auto sign public IP before, so we don't need public IP. So we're not gonna assign that. I'm just gonna click cancel here. Subnet is created. Obviously, then it so here we can create EC2 instance that will have this gateway. We're not creating here an internet gateway, obviously, because it will have a VPN gateway, not internet gateway, right? So it will receive traffic over the internet, but from VPN gateway, not internet gateway. The other VPC will have the internet gateway. So if I go to the slide here and this one, so till now, oh man, I'm gonna do that every time after the interview. So yeah, this done, subnet, and then EC2 instance, allow TCP from VPC-B customer, allow ping from VPC-B customer. So VPC-B IP range already we know we're about to give, we haven't given it, but we will be giving 10.200.0.0/16, right? So although we haven't created that and we know that we're going to create that, we're going to give that range to, we're going to tell the security group SG that, hey, this is the range we're expecting traffic from. So I'll just press escape here and go back to creating an EC2 instance now. So I'm in North Virginia, VPC, and everything is done. If I go to route table, obviously a route table automatically gets created when a subnet gets created, right? So that is the VPC office in Virginia. It's already there. We don't need internet gateway because we're going to be using here, yeah, the VPN gateway, site VPN. So here, I'm going to go to the North Virginia EC2 instance. So North Virginia EC2 instance, and I'll go for instances. So be careful here, guys, when you're doing the lab. We launch instance here, and we're going to be selecting not this. We're going to be selecting a Linux machine, and it would be Amazon Linux machine. It's just a basic Linux machine, but we're not going to be selecting the one that is showing here, and I'll tell you the difference after. Let me just put the name here. Private EC2 instance office and I hope they think they will take that long name. So yeah, private EC2 instance office, and yeah, I can go for N-V Virginia. So here the problem is that the new. So I'm just gonna first browse more AMIs, Amazon Machine Images. Then do not select the first one. It's going to automatically select that. It does not have that OpenSwan package in the packages that Linux normally has. So we're going to select this second one, which is actually the older one, Amazon Linux 2 AMI. I'm going to select that, and this will have that package built into. And when we give the yum command to install, so it's going to just install the OpenSwan. Name is there, the MI is selected, t2.micro is there, key pair. I'll just quickly create a key pair here. That is kp dash office dash in dash Virginia. Okay. dash 01 April 2023. Wow. Ontario, Toronto, Ontario. I forgot. Keep here. And yeah. So other than that, network settings, edit. Edit because that's not the VPC we need to connect. We need to connect to the VPC. Subnet is already selected. We don't need a public IP. So this means that yeah. Now we need VPN gateway for that if anyone wants to connect. We're going to be creating a security group, and that security group is also SG dash office dash uh, and dash Virginia and control A, control C, select control V. But here we need, yes, with when we are selecting Windows machines, obviously an RDP protocol is automatically selected there because you need to connect to Windows, it's RDP that you connect to. But when it comes to Linux machines, then there is SSH selected there and port 22. So it is accepting traffic from either the VPC gateway. We're going to be, adding more rules where we're going to actually put the source IP where the traffic is expected from. But here, SSH connection, we can just leave it as anywhere. It's still private if machine, so private IP based machine. So obviously, we can't get traffic from internet. We only can get traffic from whatever is coming through the tunnels, VPN tunnels. So we're going to leave the SSH as anywhere, but we're going to still add more rules here. And the second rule is we switch to diagram here. Now, ping from VPC as well. So first of all was SSH traffic. Then there is custom TCP traffic as well. So transmission control protocol or the traffic with any kind of port range that is coming from n dot. We haven't created that, but we will be .200.0.0/16. So we're saying that any kind of traffic that is TCP traffic also allowed from just this VPC. And this means that obviously whatever traffic needs to be acknowledged and confirmed or reliable traffic that is coming our way. So we're accepting that, but only from this VPC. Then we're adding one more rule, and that is the ICMP. Obviously, we need to ping now over the across the region. So we're going to be adding IPv4 ICMP. So ICMP then lets us ping, uh, receive ping here, and obviously we're only expecting that ICMP or ping packets from the other branch that we're about to create now. So just the TCP. TCP is pretty much any protocol like you're sending some data through databases or website or anything. That's why it is used. But basically, we're going to be using ICMP there to connect, right? To ping the machine from one region to another. So these three inbound rules have been created. And if I go to advanced network configuration, I'll just select this delete on termination as well. When the machine is deleting, delete the network cards as well. Other than that, nothing in storage and nothing in advanced details. So this is just the simple configuration. I'm going to launch the instance in security. So I'll be clicking instances, and this Linux instance has been deployed. If I go back here, so this much is done. Now we need to configure the other side, the other branch in US West 1 or North California. So I'm just going to go ahead and pretty much we're going to deploy the same type of instance. Then we're going to come back here to deploy all types of gateways and new terminology there. And then we're going to go for deployment of OpenSWAN and some more configuration, Linux-based configuration. So I'm going to go for the other one and create a VPC with the range. So here's the VPC and North California, US West 1. I'll go for create VPC here as well, and VPC only. Here we're going for VPC dash customer dash um, so the terminology that we used there was VPC office and Virginia, sorry, VPC customer and California. So and yeah, okay, and the IP range that we decided 200.0.0/16. So the name and IP is okay. VPC and the subnet. I'll create subnet here. Attach it to this VPC customer North California, and this is public subnet. The public subnet dash customer dash and dash California, and just for organization purpose 1A. That's it. Yeah, that's it. And click create subnet. Oops. Yeah, I didn't put the range. So 10.200.0.0/24. And then yeah, we should be good now. Subnet. We do need to have public IPs, you know, in the machine. So I'm going to select the subnet here, and I'm going to go to action and edit subnet settings and enable auto assign public IP port. So imagine that this is the Toronto branch. They need to have internet to be able to initiate a VPN connection over the internet. So we're giving that here, save, and so once that is done, I'll just switch to this diagram. So yeah, we've done. Now we need to deploy the EC2 instance here as well. And then we're going to be deploying internet gateway and route table. We can do that before or after as well. So I'll just, okay, customer VPC, edit subnet. Yeah, so we can just do internet gateway and route table, and then we can create a EC2 instance as well. So I'm just going to go back here to this, and in the VPC, we have internet gateway here as well, and that is gateways, fourth one, um, and I'll uncheck that. The default one. I'll go for internet gateway. So we're going for IGW GW dash. This is the customer dash and dash California. Okay. Internet gateway, attach it to VPC. So I'm just gonna attach it to a VPC here, and there's only VPC here. Attach internet gateway. Once that is attached, then we need a subnet or route table. If we go to the diagram here, we need a route table to connect the internet gateway to the subnet. In fact, I was creating this diagram here, so I'll just quickly create it here, and this is our US dash West 1, and this is the customers branch, employees, customer branch, whatever, and also, well, that's customer branch, yeah. And then it's VPC dash customer dash and dash California, and also 10.200.0.0/16. And then we have just created a subnet here as well. And so we just need one subnet here. And that subnet is public subnet. Has a range. This is customer and has a range of 10.200.0.0 slash 24. Okay. And then we are about to now create a internet gateway. So IGW internet gateway, and that will be connected through route table. So let's create the internet gateway has been created and connected to the VPC. Now we're going to create that route table that will connect to the correct VPC and correct subnet. So we're creating a route table. Okay, so I'm just going to go back to the North California and route table. So once we go to the route table, create route table, we did that before as well. It's going to be RT dash customer dash and dash California. Okay, route table, and it's connected to the correct VPC. But then after we create it, then we're going to configure it. So route table here. When I select that, it needs to be told that it's connected to the internet gateway and it needs to be told which subnet it needs to associate. So routes, I go to routes first and then edit routes. And then I'll tell it that, yes, you are connected to VPC, but you are also now expecting internet traffic via internet gateway. And that's the gateway we have, customer North California gateway. So we're clicking save changes. Then subnet association, I'm gonna just tell it that yes, whatever traffic you have received from your gateway, just forward it to this public subnet. So subnet association also done. Now the internet gateway and so now we're gonna deploy the EC2 instance, and that also all TCP traffic. So it's going to accept traffic only from the other VPC. If there's the traffic coming from there, so it's going to accept that only from there. So I'm just going to deploy, I'm going to go to the EC2 instance of North California as well and launch instance. And so instance name here is private EC2. Okay, I'll just copy this. And here it would be public like EC2 instance, that is customer, that is MC. Okay, so Amazon image is very crucial, the correct one. I'll go for the older. What's this? I'm gonna go for the older one, and that is 62 MI. Once that is selected, then we go down. Yeah, t2.micro is okay. Keep here. I'll go for kb dash customer EC2 and dash 01. Okay, keep here. Done. Networking, that's the main most important thing. So we connect it to the correct VPC and it gets connected to the correct subnet. Yes, we are expecting public IPs from there. We're creating a security group. So SG dash customer dash in dash California. Control A, Control C, select Control V, Okay, so the first one here is also accepting traffic, secure shell traffic from anywhere. In fact, it is the public machine, but we're going to add still the other one, like TCP. It is accepting traffic, all type of TCP traffic. It is accepting only from 10.100.0.0 slash 16 and ICMP traffic here. But we're trying because VPN gateway is on the other side, right? So VPN gateway is only here. So we're going to be connecting from here to here just to show that VPN gateway is working fine. If you want to do the same thing exactly here as well, so you can just create a VPN gateway here as well and open spawn machine there as well. So it's pretty much the same redundant steps need to be taken on the other side for both to connect. We're connecting a on-premises branch to that AWS. So here, yeah, just the TCP traffic is okay. ICMP can be added, or we don't need to add here. Other than that, I'll go to advanced network and tell that need the network card when machine is deleted. Configure storage, advanced features, no, nothing. So here, the source machine, the branch machine is configured. The Linux one, I'll just launch instance. And instances, yep, it's going to be very soon. So we have done some basic environment creation here. Now we're going to go to the virtual private gateway, and so we're going to go to the office side, North Virginia side, and we're going to create virtual private gateway first. Then we're going to create customer gateway there, and then we're going to create the site-to-site VPN connectivity as well. So let's start that. I have the screenshots on the other side just for me to make sure that nothing wrong is being selected. One small step, obviously. So even in a production environment, we always have steps in front of us if it's a pretty long target. In fact, the management says that, hey, what is your plan A and plan B? Can you just write the whole thing properly and let us know? So then we follow exactly those steps and plans. Okay, so I am going to the office side, which is North Virginia, and here I'll go down to virtual private gateway. So what is the purpose of virtual private gateway? Then we're going to deploy customer gateway, so purpose that, and then site-to-site VPN. So first of all, virtual private gateway. Virtual private gateway collects information about the office side or your site, and needs to present that information later to site-to-site VPN. Then customer gateway will have all the information of the customer side. It needs to present that information to site-to-site VPN connection. And then site-to-site VPN connection will have the required information of the source and target, and then it will be successfully created. So virtual private gateway, we're going to create, ignore this, I was saying obviously, create virtual private gateway here, and we can just give here VPG, virtual private gateway dash office dash and dash Virginia. So it says here ASN or autonomous system number. So if we go to the info area of that, so it says virtual private gateway is the VPN connector concentrator on the Amazon side of the site-to-site VPN connection. So it's the Amazon side. You create a virtual private gateway and attach it to the VPC you want to use for site-to-site VPN connection. Yes, exactly. That's what we do. So what is virtual private gateway? I'm still going to click this option and make it the middle, the two gateways. So virtual private gateway, as we just talked about it. When you create a virtual private gateway, you can specify the private autonomous system number for the Amazon side of the gateway. If you don't specify an ASN, the virtual private gateway is created with the default ASN, which is 64512. You cannot change the ASN. You've created the virtual private gateway. To check ASN from that, now we're going to talk about they didn't right here, so I'll just mention here what is gateway ASN. ASN typically provides functions such as network discovery and selection, connectivity service between MSS and core services, network, so between two networks, radio resource management, multicast, and broadcast control, and mobility. So basically, it's providing connectivity services to different gateways or different endpoints there, and network discovery as well for them. So either you choose your own ASN number, or you can choose the default one. So obviously we're going to go for default one here. I'll just put that there. I'm going to go back here to the virtual private gateway and the default ASN that would let the two endpoints, the California and Virginia, to connect to each other and to identify each other, to discover each other's network. So this would be Amazon would be taking care of that. So I'll just keep it as is and create virtual private gateway. Okay, so it is still detached. It's not attached to a VPC. When it is attached to a VPC, it will know the network configuration of that VPC. The discovery will be done by it when it is attached to a VPC, and that's the only, well, the two VPCs are there, but we're going to be selecting this VPC office in Virginia, and then attached to VPC. So once it is, so it's attaching, it's going to take some time. In fact, it takes a bit longer time. Okay. So while this is going on, we will go for the customer gateway and check that what is it and what it needs really. I go to the customer gateway here. Deleted two. Oh yeah, I created two. That's so okay, I'm going to create a customer gateway, and customer gateway normally needs the information of the customer. So this is our North California VPC dashboard and EC2 instance dashboard, right? So it just needs to know, customer gateway needs to know the IP address, specify the IP address of your customer gateway device's external interface. So the public IP that the machine got, EC2 instance received, that public IP needs to be placed here. In an example for branch, actual branch, so it would be the public IP of that branch that you can put here. So it will know that, okay, that's our customer, that's the endpoint that we are expecting traffic from. Okay? And border gateway protocol is, and so first I'm going to just see the customer gateway, CGW dash, well, it is on the website, but it is for customers. So I'll just, it's the customer information that AWS VPN side needs to know. Customer gateway info, okay, customer gateway info. And then what is the public IP of the EC2 instance in our case, or suppose it was a Toronto branch, so the public IP of the Toronto branch, which suppose it was connected to ISP called Bell. So what public IP Bell has given to that. So here I'm going to go to EC2 instance, and I'll just simply select that, and there's the public IP that has been given to that machine. I'll just select that, and go to the customer gateway and put that public IP there. Now there is certificate ARN, the ARN of a private certificate provisioned in AWS Certificate Manager ACM. If you want to give your own certificates, security certificates, so you can get from DigiCert or GoDaddy.com or Sectigo. They offer cheaper certificates. DigiCert, SSL certificates you can purchase from there with whatever type of encryption, and there are organization validation certificate, and then there are domain validation certificates, so or server validation certificates. So whichever you purchase, you can add here as well from any CA, which is certificate authority. If you don't have that, then we leave it as is, and Amazon then creates its own certificate here that with which it just does the encryption. Yep.
Yeah, a question, William. Hello.
Yeah, yeah, yeah.
Uh, is this IP address is for the customer side of public IP?
So I went to EC2 instance, which is North California, and it says customer machine, and then I selected, and yes. So the public IP, we have only two EC2 instances deployed. One is the customer and one is the public, one is the private. The public one only has the public IP. So yes, it is the customer side public IP.
We are adding this customer side IP to the office side, right?
Exactly, yes. So if I go to the diagram, so when we're creating customer gateway, it needs information about customer side of connection. So whatever public IP this machine got, we're giving it to customer gateway here on the office side. So here, we're going to leave that certificate provisioning to AWS. Also, device optional, that's again optional, but we need to just simply leave that. It just says that customer enter a name for the customer gateway device. Suppose you have deployed customer gateway on the other side, you can just give that device name here. We don't need to put any name. Or for this customer gateway device, you want to put some name there, although we have given tag here right now. So we can leave these two empty, and what we just filled the information is the public IP of the other side, the customer side. We have given it to office side. I'm going to click create customer gateway here, and I'm going to check back if the private virtual private gateway is created, which is supposed to be like, yeah, it is attached. It's green now, so it should have information in the background for uh, about the office side of network that VPN side-to-side VPN connections will be needing. Wizard will need that information. So if we go back now here, so we have created the I think we have created the machine, and obviously the customer gateway needed that machine IP, and it was public VM, so public EC2 dash instance, and it also had the SG that we created, which is so SG accept traffic from the internet because it is public machine, but also but accept TCP traffic. If we have the cross gateway to it, VPN connectivity, then accept traffic only from uh, yes. Then we have to remove that. Obviously, then only TCP traffic will be accepted from 100.0.0. So ping does come back, right? Although ICMP is only enabled on that side, but TCP is enabled here. And it's not going to be ping actually. So yeah, 10, 100, it is accepting. So this is what we created. Then we created the gateways. So we defined that customer virtual private gateway, virtual private gateway.
I have a question.
Yep.
We create a public EC2 instance on the customer side
Mhm.
because we want to ping to the machine in a office. Is that the reason?
So
Private.
we have created that gateway. So we can prove that the communication from internet to a machine that only has private IP address through VPN tunnel is possible. So yes, our proof of communication success would be a ping. So if we
So,
can ping, we can do anything else. We can just open other ports like database port if we have database access, and 443 if we have website here.
Mhm.
So, yeah. But if ping can go, then any other protocol traffic can go as well.
So accept traffic from internet, what does it means?
Right now, it is a public machine, and for our lab, we have opened this traffic because basically we will be connecting through SSH here. So we can just change it to SSH, but we need to simply connect from our laptop to connect to this machine first, then do a lot of configurations here. So that's why we're opening this traffic. Otherwise, in production environment, you would simply open SSH and port 22, and then you have to define the IP as well, which is the IP of this machine here. So we're going to be making a connection for the lab purposes. That's why we're putting it here. Otherwise, in production, no, this will not be there. Only this will be there. Or SSH also coming from only this IP here, and also if ICMP for pinging will be only connected. So yeah, this is just for the lab purpose. Otherwise, we don't do that. Okay. So here, so we've created two gateways here. One is the virtual private gateway connected to Office VPC. Office VPC. And then we have here customer gateway that is having info of customer public uh, public IP. So Office VPC having info of Office side network. So that's what the two gateways that we created, and then we're going to be going for the main one. If these two are not created, obviously we cannot create a AWS site to site VPN. Uh, so we're going to be doing that now, and it will ask information from these two. Okay, so I will go back to this console side to side VPN. Let's go there. And here I'm going to create a VPN connection. So it's the VPN gateway, VPN dash GW dash office dash N dash Virginia. Okay, so virtual private gateway, target gateway type. What is the gateway related information that needs to be given to VPN connection? And there it also says either virtual private gateway or transit gateway. I'm going to click that info here. I choose existing virtual private gateway or transit gateway for the side-to-side connection. You can select no, not associated if you wish to specify at a later time, or you want to use for a connection to cloud WAN. So when you are connecting to cloud WAN, then you don't have to use these two types of gateways. But if we go for transit gateway, we talked about virtual private gateway already. If we go for transit gateway, so transit gateway is a transit hub that you can use to interconnect your virtual private clouds or VPC and on-premises networks. For more information, see Amazon VPC Transit Gateways. You can create a site-to-site VPN connection as an attachment on a transit gateway. So you can modify the target gateway. So a customer gateway device is a physical device or software application on your side of site-to-site VPN. You can configure the device to work with the site-to-site VPN. Well, this is the customer gateway, but it's talking about transit gateway. Just that if you just want traffic only to um, your on-premises, then transit gateway is more beneficial for that. It's a network that transit hub. Uh, it's a net is a so a transit gateway is a network transit hub that you can use to interconnect your VPCs and on-premises network. So VPC to VPC connectivity plus connecting to the on-premises network as well. As your cloud infrastructure expands globally, inter-region peering connects transit gateways together using the AWS Global Info. So you have suppose VPCs in different regions, and you do want the connectivity to be with your branches as well. So then you use transit gateway for that. The following are the key concepts for transit gateways. One or more VPCs, so attachments, you can attach the following, one or more VPCs. It's just between the VPCs as well. A Connect SD-WAN third-party network appliance, an AWS Direct Connect gateway, a peering connection with another transit gateway to transit, VPN connection to transit gateway. So basically, they're saying connecting with the branch. Now, that could be multiple VPCs plus the branch, and uh, if they provide a diagram, that would be good. Amazon VPC, customer gateway, VPN connection, AWS Transit Gateway, route all traffic to and from each VPN or thousands of VPCs with one place to manage and monitor it all. So it's just connect AWS Direct Connect Gateway. So you're connecting thousands of VPCs to each other and the branch. So then you use that. We're going to be still going for virtual private gateway. That is used to just collect the information of our current environment and give it to site-to-site VPN. So I'm just going to post this virtual private gateway, and it says that do you have a virtual private gateway? So we did create a virtual private gateway. Then it says that do you have a customer gateway as well, existing or new? You could have created here as well, but we have already created that customer gateway, and this is the information for the customer gateway. Other than that, it is asking dynamic requires BGP or border gateway protocol, or what are the routing options? So if we click the info here, the type of routing that you select can depend on the make and model of your customer gateway device. If your customer gateway device supports border gateway protocol, specify dynamic routing when you configure your site-to-site VPN connection. If your customer gateway device does not support BGP specifies static routing. Now, border gateway protocol. So if we go there and I put border gateway protocol, so obviously the Cisco gurus or network gurus would know that border gateway protocol is the protocol for the internet, much like the post office processing mail. BGP picks the most efficient routes. Okay, so what does border gateway protocol BGP do? Okay, so there's I think a bit more concise one. BGP is designed to exchange routing and reachability information between autonomous systems or ASNs on the internet. Each BGP speaker, which is called a peer, exchanges routing information with its neighboring peers in form of network prefix announcement. So if you have lots of if first of all you have huge environment, big environment, and then you want that there are new environments getting created or deleted, the routes coming up and down. So you want some automation there, some automatic discoveries are going on and connectivities are going on. And then it's just trying to check that what route I'm connected to, how many routes are good, and it just updates its tables as well. So it just keeps a connection with other border gateway protocol connected networks just to exchange information about the network, the availability of networks, the routes, and what are those networks connecting to. It's going to be automatically doing all that, that where who is connected to me and the immediate network and extended networks. But we will simply assign a static one. We will tell it ourselves, hey, we are connected to just that particular IP address. And that's where only we are expecting connections from. We're not expecting any connections from anyone else or anywhere else, or we don't need to the BGP to discover new routes there for us. So that's what we need to basically do. We're gonna just be simple and straightforward and tell it that, hey, this is the exact IP we're expecting traffic from, and that's the only one that we are expecting traffic from. So once that is configured, so I'm going to just uh, put this into. So I'm just going to check that here in the document as well, this one, which I'll be sharing with you, but it's, a huge amount of screenshots. Mainly it would be this video that would be connecting all the screenshots, but since I had to create it for myself, it's a big one. Glad I don't want to miss anything. Now for yeah, so I'll just go further down. The static IP obviously would be the public IP of the virtual machine here as well, and that's what we need to put, or the customer side. Who are we connecting to? So if I just click that info here, enter one or more IP prefixes in CIDR notation separated by commas to advertise your VPC. So add static IP prefix, but whose? Yours or customers? It says local IPv4 and remote IPv4, right? So we're gonna try to put here the customer side of private IP range. Remember what is that? 10 dot 200 dot 0 dot 0. Um, so we're gonna be putting that range here, 10.200. I'm just gonna 10.200.0.0/16. We're telling that, hey, side-to-side VPN, we are only expecting communication from there. So if I just show you here, so this is the IP. So side-to-side VPN needs to know that who is going to be communicating this. So all the machines in this IP range will be actually requesting connection. So it will know that. It already knows through customer gateway what is the public IP. Now it knows that behind that public IP, what are the private IP ranges being used. So that is what we have told it. So this is just two optional areas here. We can put local and remote ranges, but we have already mentioned that here, so this is enough as well. Now you can see that there are tunnel options as well. So tunnels need to be, if we expand that, so it's showing that it's going to have, it's
Excuse
going
me.
to provide, yeah.
Uh, you put the, VPC IP address, not the, VMs. So we need a VPC IP
Yeah,
there.
IP range full. So VM
Oh,
will have just one IP, but IP range would be the IP range of the VPC. So yeah, full network. The other side is needed. Okay. So side-to-side VPN offers AWS side-to-side VPN offers two tunnels, and they are just for redundancy purpose. If one tunnel is down for some reason or overwhelmed by the traffic, and is dropping packets there, so you can use the other tunnel as well. And two tunnels will be available. We're gonna still use just one tunnel because we don't have much traffic there. So the default options for the tunnel are all okay. We don't need to really create, you know, um, so here in the tunnel generated by Amazon, you can see. So inside IPv4 CIDR for tunnel 1, what do you need to give a separate IP range here when the data is traveling from customer to client side? So should the tunnel be providing a separate IP range to you, or whatever IP your machine has or the data has is coming from, uh, would that IP be sufficient? So tunnel, when you're suppose the data is started there, so the connection has to be made to the tunnel. So tunnel would just provide an IP, this source from its side. So you want that. So we don't really need to have that. Suppose there is multiple sources, maybe there are thousands of machines from where the data is originating, and tunnel from the side there could be an IP provided to that machine as well, just to make the connection. It can be done, but we don't really need to do that. Whatever IP the client has, that is okay. For monitoring purpose, we will know that anyway. So either you give your IP range that whenever the client is making a connection to the tunnel to send data, do you need to provide an IP range there as well, separate one or not? So we're saying that, hey, if you want to provide, just keep it, let Amazon do that. I don't need to provide any range here. So it is a size /30 IPv4 CIDR block from 169 to 54 range, which is VPA range, or when there is no DHCP providing IP range, so automatically an IP range is provided. We will keep it as is. This is also pre-shared key, is that when your two sides are making connection, they exchange some
Excuse me.
kind of password. Yep.
So, if you are not selecting these two, so the Amazon will provide them IP address automatically.
Yes.
So we don't know
Exactly.
those IPs.
No, we will know when it is assigned, and it will be showing when we had made a successful VPN connection, and it will show actually which IP it assigned. This is okay. It also says it's optional, it's not required.
Okay.
And the pre-shared key. So what is pre-shared? Pre-shared is that um, when two sides are making connection, for security reason, they exchange some kind of key or password, right? So that key or password is with both sides available. Now you want to give your own pre-shared key, some kind of long username, some kind of long passphrase or password, or let Amazon generate a more difficult one according to Amazon and complex password standards. It's going to generate its own pre-shared key to share with the other side when they are making a connection to VPN. So since Amazon will be creating that, so don't need to really create that as well. Um, Also, advanced options for tunnel one, use default options. We're gonna go for basic. We're gonna stick to the basics there for site-to-site tunneling. Otherwise, we can, if you click edit, then what kind of encryption you want, phase two encryption algorithms, phase one integrity algorithms, phase two integrity of data, that nobody changed the data, encryption, what kind of how in-depth you want encryption to be, and then DH group members numbers, the permitted or Diffie-Hellman group numbers for the VPN tunnel for phase one IKE. So this is like if you're a really in-depth in security, you have done some security courses there, certifications like from EC Council or CISSP. then you would actually choose that what level of security and algorithms you want to choose here. So your secure tunnel would be even more secure. So then this is all about just securing some more. Already it is using IPsec with good encryption. So that's why we're going to stick to the default options unless you have actually a security team, certified security team that even goes further and it is edits and changes the security settings to even much deeper security. VPN logging also, you want to log that what traffic went by, how much traffic was there, how much bandwidth was used. So then you can enable that, but they will charge you for that. Tunnel maintenance, uh, tunnel endpoint lifecycle control. Tunnel endpoint lifecycle control provides control over the schedule of endpoint replacements. So on the endpoint, this site-to-site VPN might be will be configured in some kind of device. So if that device on their side, on the AWS side, which we don't have access to, if that goes down. So do you want the maintenance to be thoroughly? Although obviously we do pay for the connectivity and service availability. So they're just saying that we're going to be doing even much better job at that maintenance. But anyway, the tunnel traffic is good. Tunnel is healthy, which means that the whole traffic flow is going fine with no issues. So uh, tunnel one, tunnel two option, tunnel two would be the same as tunnel one. We are not putting anything here as well. Amazon will generate the IP range there as well for tunnel one. And it says that although Amazon is generating everything, but you want to do it yourself. So it says that it's optional. It's not required for us to do anything here. What we did on the VPN side-to-side VPN connection side, that we give a name to that, and we defined whatever the virtual private gateway that we have already created. We added there, and the customer gateway that we added here, and also that, hey, this is the other point we are expecting traffic from. So we put that too. Now I'm gonna click the create VPN connection. Now VPN itself takes some time to connect, and it's also made of the glass. So I have clicked the create VPN, and then let's take a break and come back and continue with the OpenSwan configurations on the Linux machine to initiate the VPN connection from the customer side to the office side. So let's take a break and then back. So we were talking about we had created that side-to-side VPN, this one. Now we're going to go for the rest of the configurations here on the customer side. So let's just check first of all the status of the VPN. I'll just refresh this here. And yeah, so the side-to-side VPN is okay, but obviously the connection needs to be made to it for it to work. So we're going to now configure the other side, and I'm going to go ahead. This is where we deploy then OpenSwan package inside Linux. So how do we connect to Linux, and then deploy that, and what is the command for that? So we're going to just put it there. So I have put my documents, as I said before as well, on the other side of the screen, and I'm lining up those documents on that specific page where I am. So let's connect to the Linux machine on the customer side. So I'm going to connect here to the machine, and then on the step by step, we're going to be doing some configurations, and I'll explain you why I'm doing what I'm doing. So I'll go back to this. This is the office side, North Virginia. I'll connect to And our extra is open. I'll close them. So this is the California side, and the EC2 instance, the California side is here. This is the EC2, and I'll need to connect to the Linux instance now. And there's EC2 instance connect that connects us to the browser through the browser to the Linux machine directly. So the other thing is that it's gonna log in from. Remember that we had for Windows we had administrator as the default username. So here it is EC2 user, but that's not the privileged user. It's a local non-privileged user. So we're gonna switch to the privileged user by giving the command sudo su. Well, anyway, I'm just gonna click the connect button here, and it's gonna open another screen establishing connection to the Linux machine here. And yeah, there it is. So we're logged in with EC2 user, and and that's the IP it got. And if I go for ls, there is nothing inside here, but I need to switch to the higher privileged user instead of the EC2 user. So the command for that is sudo su. Su is a super user, which which is the root. So as soon as I put that sudo su, and then you can see here the root user is showing, which means that I can do any kind of configurations here. Second thing is that we need to install the OpenSwan package. And if I go back here, so if I go for OpenSwan, so this is in the field of computer security. OpenSwan provides a complete IPsec implementation for Linux and FreeBSD. That's the other Linux flavor. OpenSwan began as a fork of the now defunct FreeSwan project. Continues to use the GNU General Public license, so it's free. Actually, it was supposed to give the purpose. So OpenSwan is an open source software which can be used for IPsec VPN access in the Linux environment. This example, well, okay, then there is an OpenSwan has been the de facto virtual private network software for Linux community since. So if we want to enable or initiate a Linux VPN connection through Linux machine, so you can use this software, and it supports IPsec, so the connection would be super secure. So that's what OpenSwan is. I'll just put this in WhatsApp as well, guys. So I'm going to go to the EC2 instance. In fact, it is logged in there. So the first command that we need to give here is uh, we need to install OpenSwan, right? So for that, the command is yum install OpenSwan -y. Well, that's the Linux command to install the package called OpenSwan. So it installs that. So it's not going to work if you have installed the other newer Amazon Linux instance, because this package is not built already available as a built-in package in that machine. So the machine that I showed, you should be doing that. Okay, once the OpenSwan package is deployed, and obviously this is Linux, so it's like um,
I have a question.
yep.
Can you copy the command on a dashboard or sorry, on a notepad?
So I will be providing.
All the commands you using in this lab, paste them in the.
See this? Yeah. So this is like 41 page document that I'll be providing you. So it has. I'm actually looking from here and then putting the commands, right? So yeah, the document is already there with all the commands. I'll be giving you that document.
Thank you.
So welcome. Okay. So here. Yeah, so first the OpenSWAN is installed, then there are series of files inside that needs to be accessed in Linux with the help of Linux editor. And just like we have Notepad in Windows, so we have file editor in Linux called either Nano or Vim. So we're going to use Vim as a Linux editor. And we're going to be opening a file called ipsec.conf inside, which is just the configuration of the IPsec side. So I'll be writing the command here. Obviously, the document will be with you at the end of the class. So there's Vim is the editor, Linux editor to open any files, and then we have to go to the file location to open it. So there's this folder /etc folder. Inside that folder is ipsec.conf. So configuration of IPsec protocol. So it says that go inside this file and check if there is one line that is supposed to be uncommented. Is that line commented or not? So when we talk about, so I'm just gonna put that document here where I tested and then I had to take my own million screenshots. So this is how the file looks like from inside. And there is this include /etc/ipsec.d/star.conf. So this just says that this line should be not commented, or the pound sign or hash sign should not be at the start of this line. If that sign is there, then this means it will not execute. If that sign is not there, then this will execute. So what it does is it just says that whatever configuration of IPsec is available, run it or use it when the VPN connection initiates, right? So use the IPsec configuration that is built into it. Now I'm just going to go inside that file. I'm in the actual machine now. I'll enter. So it opens like this, and it has so it says here as well, config setup normally pseudo logs via do not enable debug. So it just gives some know instructions of whoever created that file. So otherwise this line needs to be executed, and we just need to check that there is no hash sign at the start of it. The hash sign is there, it's not going to execute. It is not there already, so we don't need to do anything. It's just double checking that file, that IPsec configuration should be used when VPN connection is initiated. So this is just that file. How to go out of the Vim editor, and you have to just colon and WQ. So write and quit, colon WQ. W means write and Q means quit. Save and exit. So that's just one thing we did inside this. Then also we need to make some more changes, right? So what we're going to do is we're going to download a configuration document for VPN. Oh, configuration document for VPN? Where? So we need to go to the source or the office where the VPN gateway is configured, and there, here, uh, you can see this download configuration. Right? In the download configuration, so it's the AWS VPN says that, hey, whichever device you are connecting from, whichever device you're initiating a VPN connection from, I'm gonna give you the configuration of that. So you have to configure the device or the customer side in a specific way. So then only you will be able to connect from there to AWS VPN. So it says that, oh, are you connecting from Checkpoint? These are all the brands. Are you connecting from Cisco Meraki to AWS VPN, or are you connecting from Cisco Systems, Citrix, Cyber for Roam? And it goes on Fortinet, all the main brands there, F5 Networks, Generic, H3C, Juniper Networks, and there's OpenSWAN as well. So it supports OpenSWAN, but it supports all the other. So if you need the client side configuration or the other side VPN configuration, then you have to download that configuration document, which is just a text file. that gives you instructions step by step, and we're going to follow those instructions to configure our whichever device we're connecting from. Right now, we're connecting from OpenSwan. So I'm going to select that OpenSwan here. I want the client-side configuration downloaded, so I could configure the OpenSwan in a way that I can connect to the VPN. Then I'll run that ping command, whether I'm able to ping or not the private IP-based machine in Office. So I'm going to download that configuration now, and there's the text file that got downloaded, and I'm going to open that. So once I open, there are lots of instructions here related to IPsec tunnel, and there are actually these steps that we need to follow and implement, right? So that's actually 5 steps. So 1, 2, 3, 4, 5. These 5 steps we need to do exactly as they say, and then our OpenSwan will be configured correctly. Let us connect to the AWS VPN from US West 1 to US East 1 across the region. Okay. And there are some initial configurations here. So your VPN connection ID, so this is specific to our configurations that we just did now. So this is our actual VPN connection ID, virtual private gateway ID, and customer gateway ID. So this is ours one. So suppose you're doing the lab. So when you download this document, your IDs will be different than these, or whatever IDs were given to you. So your file will be different than my file in terms of just the IDs. But otherwise, we will have to follow these steps to configure our client, which is the open client, right? Okay, so the first thing it says here for configuration is this function assumes that you already have a default OpenSwan installation. Yes, we have just installed that. Place on the Amazon Linux operating system. Yes, it is on Amazon Linux operating system. I don't know about, but may also work with other distros. Suppose you install it on Red Hat Linux or any other. So it says that this configuration may work for those clients as well. So the first thing it says that go to this file sysctl.conf and ensure that its values match the following. So make sure that these 3 lines are present there for net.ipv4. These are just specific configurations for the network interface card for the EC2 instance. And if we want to connect through VPN client to the VPN server, then these lines should be there for the network card in this particular file. Okay, so I'm just gonna open the Vim editor and then go to this file, and then I need to copy paste these lines there as per the instructions from the AWS side, VPN side, gateway side. So I'm gonna move to the machine here. I have to cancel this. The machine is actually here. So the machine is open. And I'll just press enter just to clear some more space, or if I just put clear, I'll just clear the whole screen. But I want to see the above conversion, previous conversion as well. So Vim, this is the editor, just like Notepad, Windows. Vim is here in Linux. And what's the path? Path is /etc. So that's the folder we go in, and then inside this is the file, sysctl.conf. So /etc /sysctl.conf, and I'm going to go inside that. So the file opens in the Vim editor, and here it's actually empty. So we need to put those lines here. In order to edit the Vim file, editor file, we have to press I key on the keyboard, and it will change it to insert mode here. This one. So when you press I, it changes to insert mode. Then we can do anything inside. We can actually create files, or we can write anything here, right? So if I is not there, then it's read-only mode. If I is there, then you can insert something. I don't want the comment to be there. So what I need to just do it, switch to that screen here, .net. So net.ipv4, Control C, and right click and paste. So these are the three lines that are supposed to be there. Guys, just give me a second here. Just give me. Okay. So this has been copied already, and I need to save it. First of all, I'm gonna go out of the insert mode. So in order to go out of the insert mode, I need to just press the escape key. Once the escape key, I just press the escape key and the insert option is gone. If I press the I, insert comes back and I press escape, it's read only now. And then I need to save this file. So I'm just gonna press type colon here, this one, and W write and Q quit, right? So just what we did before. So we're just simply following the instructions to configure the client side, customer side, so it could initiate a successful VPN connection. So apply the changes in step 1 by executing the command sysctl-p. So yeah, we need to apply those changes. So sysctl-p, we're gonna do that in this. ctl-p, enter. And yes, so guys, sometimes what happens is that it does give error as well. Didn't give me error when I was testing it as well. But on the internet, I was seeing that if the error comes, then just disconnect the machine and connect again, or restart the machine and connect again, and then try again. But normally it should not give error. So yeah, this is it says that these are the things that were copied, and yes, it is now saved, or the changes are applied, as this second option was saying. This is done. Third option says the same thing that we did already, which is that just go to this path and confirm that there is no hash sign in front of it. So ensure that the hash in front of the line has been removed. When we checked, there was no hash sign or pound sign at the start of this line, include slash etc IPsec. So run all IPsec configuration, this means. So we have done this third part. Now there's a fourth part here that actually talks about what the actual VPN tunnel configuration, right? So it says that go to this path /etc/ipsec.d/aws-conf. We haven't gone to aws-conf before. In fact, this file does not exist. It says that here, if doesn't exist, then open it. So when you type vim and type this path, if the file is there, it will open that. If the file is not there, it will create it and open it. So that's what it's gonna do. So we're gonna actually create it because it doesn't exist there. And then we have to make some changes here. So first of all, we need to check what is this saying here. This is the tunnel configuration now, right? So AWS already told that AWS says that, or the VPN gateway says that, hey, okay, I know that the public IP of the customer machine is this 18.144. Let's just cross check that or confirm that. It's EC2. EC2 is this, and it's public API. It was 18 there written. So it's 18.144.33.84. So that's 18.144.33. So it says that left ID or the customer ID is this. I know that. But then it says I also know my own ID, right? So we haven't confirmed that yet now. So we're going to confirm that now. E.27.162. So on the tunnel side, also, so if I go back to the environment, the tunnel, or where's the VPN configuration? It is on the Virginia side, office side. So if I go there, there is a tunnel details. So the VPN gateway has been created, and the tunnel details should show tunnel 1 options. So if I go to tunnel 1 option, tunnel, it is in the tunnel details. Oops. Oh, static routes. Oh, details. Yeah, details. So it's in the details, and that is 18. No, that's the customer gateway. Okay, where was that IP? Let me check that. Refresh this information. And was it 3.227? Obviously, this is down. I was just checking down and I was like, oh no, no, that not. That is it. So 3.227.162.194. If I go to that document, 3.227.162.194. It says that yes, the customer side public IP I know, and my side of VPN gateway related public IP is also there. Then this next thing, so we confirm that yes, it is there and it's the correct IPs. Then the second thing is that there is authentication ESP. So that just takes the open authentication or OAuth. So it says that OpenSwan actually does not support OAuth or authentication ESP, which is just open authentication or OAuth. So it doesn't support that kind of authentication. So we need to remove this line in our case. So there will be some modifications we're about to do here in this configuration, and I'm going to tell you why. But we cannot make that, or we should not be making those changes here in this document. I'm just going to copy to here everything and open one more notepad and put it here. So then here I can just remove, because OpenSwan software or client doesn't really support this kind of authentication. If it was Windows client or if it was Cisco or any other, most probably it does support that authentication. Then there is left subnet and right subnet that it says. So it needs to know the private IP range of the customer VPC, and the private IP range of the tunnel needs to know that the private IP range of the office side of VPC. So we know that the customer side of VPC is 1.200.0.0 slash 16, and remote network. Remote is obviously the customer side. For the customer side, the remote network is the office, right? That's why it's saying there that the connection will be initiated, VPN connection will be initiated from the customer side. So for them, the remote network, what is the remote network for the customer? So 10.100.0.0 slash 16. So that's it. There is just the authentication protocol. Other than that, we needed to confirm these two configurations there. They are the correct IPs, and then we have to tell that what the customer side and office side private IP ranges. So this is the information we need to copy in the file that we're about to create now. This is the file that we're about to create now. In fact, the name of the file is this. It will be living in this folder and it will be under this folder. So in this file, we need to put the correct tunnel information, and we will be able to initiate the tunnel connection. So I'm going to go to the machine here, and I'm going to give this path, and it will open this. It will be a totally empty file where we're going to copy paste the correct tunnel configuration. So I'm going to go back to the machine. And I'll press enter, 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 and vim editor. Then it is /etc, but then after that Okay, in slash ipsec.d and then slash aws.conf. ipsec.d ipsec.d slash aws.conf. So slash etc slash ipsec.d aws.conf. I'll just confirm that once more. ipsec.d and yeah. So let's go ahead and just press enter. It's going to be an empty file. Yep, it's a full empty file. I need to make changes to this file, so I'm just going to press the I key on the keyboard so the insert mode is there now. And then I will go back to this changed or modified information. I'll just fill up this space and I'll copy this information and right click and paste here. So once this is added there, the correct information, then I'm just going to go out of the insert mode by pressing the escape key, and then I need to save all this information. So it's colon, write, and quit. Okay, so now the file and press enter, so it just is supposed to save this information. So then if I go back now, this is create a new file at /etc/ipsec.den. So this is another file that is not present in this OpenSwan. So this file needs to be created. So the same way we're going to open that, but it has the secret. Oh, this IP and this secret, shared secret, we were talking about that Amazon will create that itself. So this is that shared secret. It's saying that put this shared secret or the password or pass key, we can say, in this OpenSwan. So when OpenSwan tries to connect, if I go to the diagram here, when OpenSwan tries to, or the EC2 instance tries to make a ping connection, so this password key will be checked. So that same password key is in AWS because Amazon generated that. This when we downloaded the file, so Amazon gave that file. Hey, this is the key you should also have. If you don't have that, so then I won't let you connect. Right? And this is the symmetric key, which means that both parties have the exact same key. And asymmetric would be that there will be public key available to everyone and private key only to the user. So this is the symmetric key that they're giving. I'm going to now create this file and then I'll put this, copy paste this information there. When OpenSwan connects, this information will be checked and then only it will be, and the VPN connection will be successful. So I'll go back to the machine. Again, the Vim editor is needed. I'll just clear some more space. Vim/etc is the folder, and then I'll just check again by going back. ipsec.d, time aws.secrets. So ipsec.d slash aws.secrets. ipsec.d aws.secrets. Yeah, secrets. So I will be opening that file, but I'll just copy this information. So this is the IP of that EC2, public IP of the EC2 instance. And this is the IP. Remember that this is the IP of the EC2 instance, and this is the tunnel or the VPN gateway IP, right? And then this is the key. Okay, so I'll just copy this. We'll see. I'll go back here. I need to open that file first. VPC ipsec.d/secrets. So then insert mode again. I'll press the I. So insert comes here and right click and paste, and then go out of the insert mode, press escape key.
You
and
missed
yeah.
you missed the closing quote at the end.
Oh, thank you. All right, thank you very much for this. Okay. Oh, okay. That was a close one. Otherwise, we would have then troubleshooted. Uh, I should just put the code, but I just messed it up already. Okay. And paste. Right. Thank you. And just go for out of the mode, escape, colon, W, U, enter. So the secrets is also there. We created those files ourselves, so the path was supposed to be good and the file names were supposed to be exactly the same. Just double check as well. Now, if we go to their documentation, so for the tunnel 1, this was the configuration. If you wanted to go for tunnel 2 configuration as well, you can just go ahead and configure it on your side when you're doing the lab. But pretty much, we just need at least one tunnel to be functioning so we could make a connection. 5 steps are done. Now there are certain commands that we need to run, like just saving, first of all, checking the status of VPN and saving it. So on the other side, I'm just scrolling down to that level where the commands are showing. So systemctl start IPsec is the command. If I just show this screen, so let's start the IPsec services in the OpenSWAN. So this is the systemctl IPsec, and then there is another one called systemctl status IPsec, right? And yeah, that's what we were expecting here, active running. So sometimes it does mess up. So then try to run them again or check the whole configuration or restart the machine and then try it again. But systemctl start IPsec, I'll just run that command. Systemctl start IPsec, enter. Okay, so no news is good news. Otherwise, if there were any issues, it would give some red lines there. And then systemctl status IPsec. So much the above one, the start is status. Status. Enter. Okay. Okay, so it's active running. Any small step in the back, all previous steps, any small step missing, this gives error. So way back when I was doing that, so then I had to really troubleshoot a lot this one at this stage, and I had to go back and trace back the steps. So once this is there, active running means then what? We can go to the tunnel details and check out from there as well. This is the obviously the client side, the customer side says active running. So we need to go to this side as well and check it out. So tunnel details is showing here. I'll refresh that. And it hasn't, so I'll go to details, tunnel details. It says right now unavailable for now, but it should be up soon. So I'll just switch somewhere else or click somewhere else. Check out. Yep, everything seems okay. Tunnel details. So either it should be up right away or it will be when I start pinging from there. So there will be traffic going to the tunnel, then it will be up at that time. So it could be any of those things. I'll just switch to another mode out and then come back to the side-to-side tunnel here and just refresh some more. Oh, there you go. Now the down changed to up. Another, okay. And then pending instance, because we don't do that every day, right? So when we're doing that, it better work. So once it is up, we're expecting the ping to work from North California to North Virginia across the region, which means that, I'll go to the instance here and so first of all, I need to check the private IP of the other instance. So I'm going to be in North Virginia. There's the instance, and this is the private IP 10.100.0.104. So I'll copy that and go to this instance. Its private IP is 10.200.0.37. So I want to ping. So I'll just paste here and go to ping space and enter. I know it should have started pinging, but or I should press enter because the screen is not showing. So we're going to invite some of that. And on the other side, the tunnel is up. And the IP is of the machine is 10.100.0.104. So I'll go here. Same lab I just did a few hours ago. Okay, so there's a document that you can follow. It has a few million screenshots, but it pretty much covers a lot. I will pause the video and troubleshoot, and if I get the solution, I will simply start recording again and make it part of the video that, oh, okay, that was something that we need to do. Or after some time, it started working. So something like that. So I'll pause the video. So resuming. Alright, guys, there's one more thing, and there was a step missed. We have to do a root propagation as well. And that root propagation is set up in the subnet. So there is that private office subnet, the default subnet. We have to go to, the route table. We have to go to the route table. This is the route table for the default VPC. And there's root propagation and edit root propagation. So that was supposed to be enabled as well. This step was missed. So one step, I think one step was missed. It is office network. Application. Okay. And it works, guys. So root propagation was the main thing. So watch the video till the last for one more step, and it works fine. So root propagation, I'll just so it's the North Virginia. I'm just creating this route table, the default route table that is, not the default route table, the other one. And then go to route propagation and edit routes. Um, Table, I'll just show that here as well.